Hello everyone. In this video we are going to look at matrices. We'll start by defining what a matrix is. A matrix is an array of numbers or elements which are arranged in rows and columns. So what we mean by rows, we are talking about simply numbers which are arranged in this order. So this is what we are calling rows. Then when we talk about columns, we're talking about these which go up and down. So these are what we are calling columns. So a matrix is an array of numbers or elements which are arranged in rows and columns. A matrix can hold any number of columns and rows. So you can find that the matrix is having 4 rows, 3 columns, can have any number of rows and any number of columns. So that's about a matrix. So because of those holding of different number of rows and columns, this is what brings us to what we call types of matrices. So there are various types of matrices. So types of matrices. So to start with, we can look at what we call a row matrix. So number 1, row matrix. So a row matrix is any matrix which possesses one row and some particular number of columns. So as long as the row is 1, the number of columns do not matter, then that one is going to be called a row matrix. So a row matrix, I can give an example of a row matrix. So in a row matrix, maybe we say matrix A. We know that matrices are represented by a capital letter. So if this is like this, we can call it a row matrix. Why are we calling it a row matrix? Because we have got only one row and we have got 2 columns. We can also have this one. So this one is also called a row matrix. Why? Because we have got one row and 1, 2, 3, 4, 5 columns. So that one is also called a row matrix. This one we have got 2 rows, one row and 2 columns. So that one is also called a row matrix. Just a quick look at what we call order of a matrix before we move on. Order of a matrix is written by number of rows by number of columns. So these we are calling them number of rows, and then this one is a number of columns. So that is how you write the order of a matrix. Just a quick example. If you are asked to state the order of this matrix, matrix P, remember a matrix is also always represented by capital letter. And they ask you what is the order of this matrix, you say matrix P. As the order, you count the rows first. So remember, the rows are like this, these which are running from east to west. Those are rows. So how many can you see? We can see 1, 2. Hence we've got a 2. Then you say by. So you say 2 by. Then how many columns? Remember the columns are these which move up and down. So I've got 1, 2, 3 of them. So this is matrix P is a 2 by 3. So that's how we state the order. Just a quick one. If we are given this one, and we are asked to state the order, so B, we'll first count how many rows do we have? 1, we have only 1, times the columns we have 1, 2. So it's a 1 by 2. So that is the order, 1 by 2, this matrix. Okay, the next type of matrix we have got, which is number 2, we are calling it a column matrix. A column matrix. So a column matrix, this is a matrix having only one column but a variety number of rows. So that one is a column matrix. So we can give an example of this B. As long as the column is 1, it doesn't matter the number of rows. So it can be called a column matrix. But it should be clear that the rows are more than the columns. That's when you're going to say the matrix is a column matrix. So it should be very clear like that. In this case, we are clear that this is one column. The number of rows are more than 1. Also, having this example, it's still fine. So this one is also called the column matrix because the column is 1, but we have got 2 number of rows. So that's a column matrix. So a matrix having only one column and a variety number of rows. The next type of matrix that we're going to look at, which is number 3, is called a zero matrix. So as it sounds, a zero matrix, this is a matrix having only zeros inside. All the elements are zeros, then that is a zero matrix. You can give any example of your choice. You can have this one. You can have this one, which is 2. Oh, sorry. We said zeros. 0, 0, 0. Any matrix which is going to have zeros inside. You can have matrix C, which is 0, 0, 0, 0, 0, 0, 0, 0. So all these are going to be called the zero matrix. The fourth type of matrix that we have, we can call it number 4. It's called singleton matrix. So a singleton matrix is a matrix having only one member inside. That is the one we're calling a singleton matrix. So if matrix Y equals, with one member inside, there's only one member. As long as there's one member. As long as there's only one member. So that's a singleton matrix. Then the other type of matrix that we're going to look at is what we're calling a square matrix. A square matrix. A square matrix, this is a matrix having same number of rows and columns. You find that if you look at this matrix, you count the number of rows and the number of columns, you find that they are of the same number. It doesn't matter what is inside the matrix, but or inside each row and column, as long as the number of rows and columns are the same. So you can have a 2 by 2. Maybe here, anything. So here, if they ask you for the order, you will say 1, 2. So M has got the order 2, and then the columns are also 2. So this is a square matrix. You can look at another matrix. Maybe it's having if you count if you want to write the order, you're going to count the number of rows first. 1, 2, 3 by 1, 2, 3. So this is a square matrix because the number of rows and the number of columns are the same. So that one we call it a square matrix. The next one which we're going to look at, which is number 6, is called a rectangular matrix. So a rectangular matrix, this is a matrix which has a different number of rows and columns. As long as the number of rows and columns are different, then we're going to have a rectangular matrix. Examples: we can have matrix A equals 4, 3, 4, 5. So this is a rectangular matrix. We can have matrix B equals 4, 2, 3, 6. So this is a rectangular matrix because the number of rows 1, 2, 3, the number of columns are 1, 2. This one has got one row, 1, 2, 3, 4 columns. So as long as the number of rows and columns differ, then what we are having is a rectangular matrix. So that is what we are talking about. Okay, we go to the 7th. The 7th is horizontal matrix. So for us to say the matrix is horizontal, a matrix of the order mn. When we say order mn, we mean this is the number of rows and this is the number of columns. So a matrix of the order mn is said to be horizontal matrix if n is greater than m. So that is when we say the matrix is horizontal. What do we mean? It means that the number of columns are more than the number of rows. So for instance, if you have got so as your matrix, and then we are having as a matrix Y. So this matrix is going to be called the horizontal. Why? Because if you look at the order, it is 1, 2, which is 2 by 1, 2, 3, 4. And this is our M, and this is our this is our M, and this is our N. So you can see that N is greater than what? M. Hence, this matrix is going to be horizontal. In short, it is elongated in the x-axis. So that's why we're calling it horizontal. So then this brings us to the next matrix, which we're calling a vertical matrix. Number 8, vertical matrix. So a vertical matrix is the opposite of horizontal matrix. So in the vertical matrix, the number of rows are going to be more than the number of columns. So any matrix which appears like this, maybe you can call it matrix P equals 3, 4, 5, 6, negative 0, negative 1, 2, 4. So this matrix has been elongated in the vertical ways. So hence we are going to call it a vertical matrix, and in this case the number of rows are more than the number of what? Columns. So this one we are going to call it a vertical matrix. Then number 9, we are going to have what we call a diagonal matrix. A diagonal matrix is a matrix having zeros everywhere except in the principal diagonal. So if you have got a matrix, this is what we call a principal diagonal. This diagonal which goes this side is what we are calling a principal diagonal. So in a diagonal matrix, here you find numbers which are not zeros. But everywhere else, they are going to be zeros, like that. So this matrix is what we are calling a diagonal matrix. So that is how it is defined. So a diagonal matrix is a matrix having zeros everywhere except in this diagonal, which we call a principal, diagonal. So that is about a diagonal matrix. So from this diagonal matrix, then we call the last one, which we call an identity matrix. An identity, number 10, identity matrix. An identity matrix comes from the same one which we are calling a diagonal matrix. But for this one, everywhere else, yes, as it is, there will be zeros. But in this principal diagonal, we are going to have what we call ones. Only one should be here. 1, 1, 1, and 1. Then this one, we call it an identity matrix. I can give another example here. Matrix B equals, if it's a 2 by 2, it is going to have 1 there and 1 here and 0 there. If it's a 3 by 3, it's also going to have 1, 2, 3, 1, 2, 3. But everywhere else, you need to have zeros. So this is an identity matrix. So if an identity matrix is multiplied by a matrix itself, the matrix always returns. So this one, identity matrix, it is represented by letter I. So that is the identity matrix. So if you multiply any matrix by the identity matrix, the answer is the matrix itself. So the identity matrix behaves as if it is a 1. Okay, we have come to an end of the introductory of the types of matrices. So remember, we have got 10 types of matrices in this video, but there are various other types of matrices which we have not looked at. So I just wanted to give an introductory part to the matrices. See me in the next video as we start to work on the 2 by 2 matrices questions. Thank you very much.